This is the spectrum of the entire 40 meters and 41 meters bands.
Buonanotte a tutti. Ciao Marco, buonanotte a tutti. TQ59, greetings from Italy.
This project is sponsored by PCBWay. From concept to production, PCBWay provide cutting-edge electronic design solutions for global innovators including hardware design, software development, mechanical design, product testing, and certification. PCBWay engineering team consists of experienced engineers in electronics, embedded systems, and product development. They successfully delivered hundreds of projects across industries such as medical devices, industrial automation, consumer electronics, smart home, and IoT. Hello? A radio Panadapter or panoramic adapter is a device or software tools used in amateur radio and other radio communications to display a wideband spectrum view of signals around a selected frequency. It allows operators to visually monitor a range of frequencies in real time rather than just listening to a single frequency. Panadapter shows a graphical representation of signal strength across a range of frequencies and helps identify active signals, interference, or unused frequencies. There are generally two types of Panadapters: hardware-based, dedicated external devices that connected to a radio's IF output, and software-based Panadapter that use SDR receivers like RTL SDR and SDR Play or Kiwi SDR to display spectrum data on a computer monitor. Specifically in this project, I developed software-based Panadapter using my SDR Play SDR radio receiver, but as I mentioned earlier, another type of SDR radio can also be used, such as a cheap RTL SDR dongle with appropriate software. This time I decided to modernize my old vacuum tube high-frequency receiver model Trio JR500S. An excellent explanation of how to install and how the Panadapter works can be found on Scott's Baker website, from where I took the input part of the buffer and some pictures. Most old tube and transistor receivers are of the super heterodyne type. The incoming RF signal mixes with desired frequency from a local oscillator to center that frequency around an intermediate frequency. In our case, this intermediate frequency is 8.9 to 9.5 MHz. So we should place the buffer amplifier immediately after the first mixer as shown in the diagram. So here. The SD receiver needs to be able to handle the intermediate frequency from your radio. My Trio JR500S has a 9 MHz intermediate frequency, but your radio may differ. It's important to notice that the frequency on your SDR receiver will be centered around the IF, in my case 9 MHz, which is no problem for my SDR Play. Regarding the connection point of the Panadapter, this is the schematic of my radio, and the board should be connected immediately after the first IF transformer, IA, at the point marked with this yellow arrow. The board should be mounted as close as possible to this point so that there is no additional interference due to the length of the cable. In almost all super heterodyne receivers, the Panadapter should be connected immediately after the first IF transformer. And now a few words about the buffer board. tube radios are often very high impedance signals. They are meant to drive loads into the hundreds of kiloohms or even into the megaohms. If you take a regular amplifier designed for a 50 ohm input impedance, you'll suck the signal right out of your radio and there will be nothing. You'll completely load down the receiver. Therefore, the buffer amplifier shown in the diagram below has a very high input impedance and a low output impedance, so it does not affect the received signal at all. The buffer has two active stages, a JFET source follower to present a high impedance to the IF filter and therefore minimize any loading on the main signal path of the radio. Then follows the BJT transistor as an emitter follower to provide impedance transformation for a following filter stage. And finally, I added a very simple 10 MHz 3 decibels low pass filter consisting of a single inductor and resistor. Here's what the PCB looks like mounted in the radio. I took power from the mains transformer through a rectifier and the output signal from the buffer comes out through this small hole and should be connected to the antenna output of SDR radio. Here is the first IF trafo, and input of buffer is connected directly to one pin of IF trafo. Now we will look at the signal spectrum of the entire 41 broadcast band as well as the 40 meter amateur band. This is antenna. This is my Trio JR500S receiver. Here is the first IF trafo. Cable goes to this buffer circuit with battery and output of buffer to the SDR radio and appropriate software SDR Uno. Here is the full 41 meters broadcast band.
After he sees the results of this, he says, Poparano dopingue Buffwe que memorias hacia la memoria esto lo provoca. Nunca se trata de pan.
And here is the first IF frequency. So with this Panadapter, I visualize signal from this old vacuum tube radio. Now we will look at the signal spectrum of the entire 41 broadcast band as well as the 40 meters amateur band. In fact, these are the frequencies on which I had the best reception at the time of recording this video. First of all, on the SDR Uno software, we need to set the first IF frequency of the radio receiver, and in this case it is about 9.2 MHz. We go to custom, 9 MHz, 9.2 MHz, and start SDR software. The vacuum tube radio receiver is powered on. Now we need to set the preselector knob of the radio to the position where we have the best reception. This is the spectrum of the entire 40 meters and 41 meters bands. These are broadcast stations at 7 megahertz. And as we see, this is SSB signal. On 40 meters.
Tango Whisky, Cora 2, Guatemala, Torino Whisky.
As we see, this is first IF frequency of this radio receiver. And this is 40 meters and 41 and 40 meters bands. Here's another signal of 40 meter amateur radio.
Due GTW, Golf Tango Whisky. Va bene?
And also all broadcast stations on 41 meters. Now we can select the desired signal, and with the help of the software we can set many different parameters which are almost impossible to change directly to the radio hardware. As an example, filters, noise reduce, etc. You can choose directly radio station or with mouse scroll. And again amateur radius on 40 meters.
Pacific Ocean DX. Number 0, Foxtrot, Germany, Lima. Pacific and Indian Ocean DX. Panamai.
So in this case we use only the input part of the radio up to the first IF transformer, and then all the electronics of the radio are replaced with the SDR play, SDR radio and the appropriate software.
Roger. TQ59, greeting from Italy. Ciao. Aspetta. Buonanotte a tutti, siete lì domani. State bene, 0 Max QRT.
or AM broadcast.
Gruppo, sono ore e butti. Sotto, sulla governante che è meglio. Buonanotte a tutti. Ciao Marco, buonanotte a tutti.
By integrating an SDR-based Panadapter in my Trio JR500S, I've brought modern spectrum visualization to this classic tube radio and this upgrade and chance functionality while preserving the vintage charm of the receiver. If now go back to the original tube receiver, we will see that receive the same station directly on the receiver, which is confirmation of the fact that the buffer amplifier does not affect the original input signal at all. So let's try.
Bizarre thing for the Republicans to oppose, but so there's tremendous work. I mean, that's the idea here, is that
Например, провинция Джетла, где-то обычно проходит вечером, а днем молодожены отправляются на прогулку с смелыми близкими.